Hello everybody, in this video we will look at overfitting and underfitting concepts. These two are fundamental in building a model in machine learning. Let us look at the data points as shown here and let us try to fit a function which passes through every data point. Now let's say we got a new unseen data. Our model prediction will be way different compared to the actual value. Thus, our model performs poorly on unseen data when compared to the training data. So this is generally known as overfitting. Now here are some symptoms of overfitting. It shows very good accuracy on training data, but it shows poor accuracy on test or unseen data, which means our model fails to generalize. It only specific to training data. Why does overfitting occur? There are various reasons. One of the reasons is we try to believe our training data so much that the model assumes that training data is everything, and hence it does not work well on the unseen data. And second, which is related to that, is it tries to fit an overly complex model, as we saw in the example. Now let's look at underfitting. Let's fit a model which ignores most of the data points. As we see here, it considers only 2 data points. Now when an unseen data point comes in, the model again performs poorly. Some of the symptoms of underfitting: it performs poorly on training data as well as on test or unseen data, and again the model fails to generalize. Why does underfitting occur? Obviously we try to underestimate the training data. We consider only few data points, and related to that we fit a very simple model, whereas we could have tried a little more complex model. Now that we understand what is overfitting, let's try to understand how to avoid overfitting. There are many techniques to avoid overfitting, and here we will cover 2 of the most commonly used techniques. Generally we split the data into 3 categories: train, validate and test. It could be 70% of training, 15% of validation and 15% of test, or any such combination. We have given some common percentages here in this slide. Now we fit a model on the training data and then evaluates its accuracy on the validation data. If it is not good, then we can go for another model and repeat the same step. We can do this until we find a model which performs well on the validation data, and then we use that model to predict or to test data or the unseen data. The key here is we would like to evaluate our model on a validation set, which is also called holdout set, where it is not being trained on. So that is the key in this concept. The second technique is known as cross validation. Here the training data is split into k folds. K could be any number, generally from 3 to 10, and in each fold, one fold is reserved for validation, whereas the rest of the k minus folds are reserved for training. For example, here k equals 4. We can see in the first iteration, fold number 4 is used for validation. In the second iteration, fold number 3, and so on. So again here we can fit the model on training and the model is evaluated on the validation set, and then every fold gets a chance to be in training as well as in validation. That way our model could be robust. And then when we find the right model, we can then evaluate its performance on the test data. So this is all about overfitting and underfitting and techniques to avoid them. I hope you like the lecture. Thank you for watching.